This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. This week we welcome back Roland Vierra and Bob Blochinger. We're going to continue our discussion on moisture-related issues affecting wood and concrete substrates and flooring. Before we get started, let's thank our sponsors. They are the reason we can continue doing the show. Our marquee sponsor is Instascope at instascope.co. Our association sponsors are the American Industrial Hygiene Association at AIHA.org, the American Conference of Governmental Industrial Hygienists at ACGIH.org, the Cleaning Industry Research Institute at CIRIScience.org, the Indoor Air Quality Association at IAQA.org, the Restoration Industry Association at restorationindustry.org, the Institute for Inspection, Cleaning, and Restoration Certification at IICRC.org, and Healthy Buildings America 2021 at HB2021-America.org. Industry sponsors are AEML Laboratories at AEMLINC.com, Particles Plus at particlesplus.com, Grey Wolf Sensing Solutions at greywolfsensing.com, TSI Inc. at TSI.com, and Healthy Indoors Magazine at healthyindoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. Congratulations go out to IAQ Susan Valenti in Andover, Mass., who was first to correctly identify extratropical cyclones as the meteorological term defined as synoptic scale low-pressure systems that occur in the middle latitudes and often contain a cold front and have a length scales on the order of 500 to 2,500 kilometers. The IQ Radio Trivia question for today, April 23rd, 2021, has been sponsored by TSI Inc., an industry leader in precision instrumentation for the monitoring of indoor air. Learn how to expand your IAQ investigations at tsi.com. Here is today's trivia question. In real life, who was the original owner of the ship that brought fictional character Vito Andolini to the United States? Back to you, Joe.
Thank you, Cliff. Okay, so today's guests are Roland Vierra. He's the president and CEO of Flooring Forensics of San Jose, California, and he's been a third-party claims consultant for more than 35 years. And Bob Blochinger, raised in New York, working in the family construction business. Bob began his career in the flooring industry in 1970, doing carpet cleaning and installations, and also doing water damage and fire damage restoration work. He has since expanded into much more detail into the flooring industry. During the 90s, his company started to service architectural and interior design trade with high-end floor covering product sales and installation. And he also does expert witness work related to flooring and installation issues. Let's go right to the PowerPoints, John. And Roland, why don't we start with you, and we're going to jump right into that third one. You guys did a great job on the first show talking about forensics and what it is, and then dove into some great case studies. I'd like to get started here again. Let's, Roland, why don't we jump up with you and start on this church gymnasium project.
All right. That sounds like a plan to me. This was a case that I got called into. It was an interesting case. It was a gymnasium at a church, and the claim was cupping. It was a solid maple floor. It was installed over a floating plywood subfloor. So essentially what they had was they had a concrete slab that was on grade, and then they put a sheet membrane, a visqueen type of product, over the concrete, and then they put sheets of plywood, just loose laid, so that the plywood was floating over that membrane. And then they went ahead and they nailed the hardwood, the maple hardwood, right into the plywood. And what ended up happening was half of the floor cupped, only half. And it was almost exactly half, and there was a straight, almost a straight demarcation where you could see, you know, what the hell happened. This is half here and half is not going on over there. So that was the big question. And there was, I did some preliminary moisture testing using my pin meter, and found out that the moisture content in the areas of the cupping versus not cupping was noticeably different. So these photos right here show the cupping that was going on in the floor. That's a typical representation. And let's see if there we go. Okay, so what had happened then is we eventually went ahead and we removed the hardwood, and we got down to the plywood. And when we got down to the plywood on the half that was cupping, look at that moisture content, 32%.
Mm-hmm.
That's a lot of moisture. So we dug further, and we actually removed some of the plywood. And what we discovered was over the entire floor, 100% of the floor, we discovered that the fasteners, the cleats that the installer had used, had actually punctured the membrane. So there were literally thousands and thousands of holes in that moisture vapor retarder membrane that they had put down. You can see on this picture on the right there, that is a cleat, the tip of a cleat that came through the bottom of the plywood. It went through, the photo on the left will show you the exact schematics of it. That white is a foam that the plywood was floating over. The black was the visqueen, the plastic vapor retarder, and then the gray is the concrete. So it will show you that that cleat went right through the foam and right through the membrane. And I think I have a picture of a membrane in this with some holes in it, possibly. Let's see. Nope, I guess not. So anyway, so what we did was, the remedy to this, of course, was to pull the whole darn thing up and reinstall everything. But the question still was, why was only half of the floor affected by cupping? The other half wasn't. And yet, over 100% of the vapor barrier, we had holes from the cleats. Well, we dug back. The building had been built back in the 1940s. And when we dug back, it turned out that this addition, half of it had been cut into the side of a very, very shallow hill. And the other half of the floor was sitting on a grade that was fill. It had been dirt that had been brought in. And what happened was the area where it had been cut into the hill, that was the area that was not cupping. But the fill, where the fill had been placed, that was the area that was cupping. The theory was, and we never went down below the concrete to test this because, you know, the client doesn't want to pay for that if they don't have to. But we suspect that the fill area was probably looser and more prone to moisture movement. For all we know, the side of the hill, you know, might have been rock. For all we know, like we know that building was over 60 years old by the time we got to this point. So we suspect that that's why half of the floor was affected and the other half was not affected. But the ultimate cause was the installer going ahead and using the fasteners that were too long for the application. And in all fairness to the contractor and the hardwood floor contractor, and he's a very good personal friend of mine, and so I hated to break the bad news to him, but hey, what could I do?
Yeah.
You know, he was confined. But he couldn't do a very, very thick build in this particular installation, just given the existing elevations that were already there. His only problem was he miscalculated when he added the total thickness that he had available to him versus the length of the fasteners that he was using. It was a simple mathematical error. He did it in his head instead of doing it on a piece of paper. He miscalculated, and he ended up replacing the entire hardwood floor.
Wow. That's got to be a costly mistake.
It was an extremely costly mistake, and one that he swears he will never make again. You know, so he'll never make that mistake again. I think that's good, you know. But this is the type of a mistake. Now, this man has years of experience, and this man does hardwood floors in gymnasiums almost exclusively. And this is the type of a mistake that would fly under the radar. You would think, well, that's silly. The fasteners were too long for the, you know, for the total build. And you would think, how does an experienced person make that mistake? But mistakes happen, and this is it.
Absolutely.
Hey, Roland, because it was a mistake, wouldn't completed operations insurance cover that?
You know, I don't think so, because it's still a workmanship issue. So I don't think so. And, you know, this particular gentleman that owns this particular hardwood flooring, you know, he's a real straight shooter. He made the mistake, and, you know, I know what his response was after we dug everything up, and he was there with me when we dug it all up. Hell, I made him dig it up. You get the saw, you cut into it, you know, you pry this stuff apart, and I'm going to be there watching. And, you know, once we got down there and he looked at it, and he knew exactly what happened as soon as we pulled up that piece of plywood. And, but he was the type that, well, I mean, I made the mistake. I'm going to eat this, you know, and that's that. So that's what he did.
Okay.
Any idea how costly of a mistake that was?
Yeah, it was, by the time you added the additional costs of having to dispose of that existing hardwood floor, he was somewhere a little bit north of about $100,000.
Wow. That's a pricey mistake right there, Roland.
Yeah.
All right. Well, let's jump over to Mr. Bob Blochinger. And John, can you put up Bob's next case study, please? School moisture testing project. Bob, by the way, welcome back. Good to see you again.
Thank you.
So what do we have going on here, Bob?
I believe this school was just east of Tampa, Florida. And as you can see, my meter, the Tramex meter, was 56% relative humidity, 72 degrees, with a dew point of 55.9 and a grains per pound of 64. The RH is considered within, I'm going to say, our normal service range, because we like to see 45 to 55. So that was that. And the VCT would be the next slide.
And you're in a hot, humid climate too in this particular case, right?
No kidding.
Okay.
We got alligators down here. So here I'm showing the space where the VCT shrank. And you can see one tile sits at 1/64th and the other one sits at 3/64th. This is an acclimation issue, which is very typical, where the VCT may be delivered to the job site, perhaps weeks before, but there's no HVAC system operational. And many times it's installed on these bigger jobs without any HVAC system. So therefore, when the HVAC is turned on and it gets cooler, of course, the vinyl will shrink. And that's what I'm showing there.
How big of a project was this? Okay, we're going to see some pictures here.
Yeah. I'm going to say about 30,000 square feet.
Okay.
This just shows a room, typical room, classroom. And if you look real close at the window reflections, there's some waviness going on in there. And that's all right there. That's all, I'm sorry. So that picture just shows what I explained, nothing specifically. Here, you can see the adhesive, the clear set, has become what I call pancake mush. Moisture has passed through, attacked it, broke it down, and the black lines you see is actually the adhesive oozing through, and general soil is being collected by the adhesive that's oozing through. Now, the black substance you see, no one has yet to identify that for me. Some say it's a moisture barrier. If that's the case, it's not working. Even the GC has not responded yet. This is still an active claim, even though it's about a year old. And on the tile that's lifted up, you can see the black along the edge. That's adhesive. That's still a little bit tacky, but it's the soil is being attached to the adhesive. And in this particular job, if I remember correctly, there was moisture testing performed. I think it was the ASTM 2170. However, it was performed without HVAC system operations. Therefore, it negates it.
Interesting.
And that's just a close-up of the mush.
Next slide, John.
Yeah, next slide. Same picture, different angle.
Okay.
There you see the content after I scraped away. We still don't know what that black substance is. It is not the typical gray color of finished concrete, but we're at 6.4, which is basically spiked. For VCT with adhesive, we're looking at the 3% or less as a norm down here. So whatever that black is just not working. And
I'm curious, Bob, was that, you say the norm down here? Roland, you're in a more dry climate over in Southern California. What would the norm be there?
Actually, I'm in Northern California.
I'm sorry.
Just about 50 miles south of San Francisco. So normally what I refer to as the background. Okay, so normal using the Tramex meter like Bob is showing here. Normal would be between 4 and 5, maybe 5 1/4. That would be normal. Once I get up to about 5 1/2, I start to get a little concerned and a little worried. Anything over 6, I think, necessitates further evaluation.
Okay, Bob, I'm sorry. Let's go back to you.
Different areas, different conditions.
Yes.
Here's just a close-up of the black ooze, and the black is general soiling. There I'm just showing the scale with the gauge card of rolling traffic that has marked up the tile. And also there's a really bright spot just below the card. Right. That's a lump. That's probably somebody, forgot to bring the broom on that one.
Okay. So what was the outcome on this one, Bob? You're still working on it, I guess, but what's the theory on it?
It's still being negotiated due to the size and COVID, and it is a school. So I don't know the outcome of that. I did have another school with similar conditions, and the general contractor went ahead and ripped everything out and replaced it. I was privy to that inspection. It is a lawsuit as well. And about a month ago, I got an email from the attorneys with a photograph of the exact same condition as for the reason they ripped it up. which means there was no change within the building as far as ambient conditions. So this guy's going to get to do it the third time.
Wow.
It gets
Wow.
messy.
That's rough. All right. Well, let's move over to Cliff. Any follow-up?
Nope, not on that.
All right. Let's go over to the next one, John.
So this was a junior college project up here in downtown San Francisco, actually. And the floors had been installed, linoleum floors, had been installed back in 2012 or 2013. We had 14 floors of corridors and classrooms. We went on in, and the issue was the linoleum was bubbling. And the bubbling had started to occur 6 to 9 months after the floor was installed. And over the course of a couple of years, the installers would return, cut open the floor, scrape up the old adhesive, put new adhesive, and put the floor back down, only to have bubbles showing up elsewhere. And so this eventually the owner, the junior college district, essentially got upset and said, hey, we're not going to have this anymore. Now, to be honest, and most of these cases, the way they go is there wasn't just a problem with the floors. There was lots of problems. There was actually 2 buildings, but we concerned ourselves with the bigger building, which was the 14 floors. So it wasn't just the linoleum guy that was on the hook. There was roofing problems, there were electrical problems, there was all sorts of problems. And that is very, very typical for most construction defects cases, because what will happen is once somebody discovers something, and I think the floors were the first thing to be discovered, then they actually start to go looking for other stuff. Mm-hmm. And what they do is they hire themselves an expert that goes through and just starts tearing everything apart, right? And so before you know it, you got claims against almost every subcontractor that was out there, plus the general contractor, and it just snowballs. So anyway, going back to the floors, we took about a week's worth of time over a Christmas break. We went in, we tore up the floors in a number of different locations so we could take a look at the bond line. We also ran a number of both calcium chloride and RH moisture testing. What we discovered was, first of all, the moisture content on all of the floors, and all of these floors were above grade. The moisture content was acceptable, not by a small amount. It was really acceptable. It was well within acceptable ranges. And what we noticed that the adhesive was releasing from the concrete itself. So the adhesive was releasing from the slab surface, and we did have the presence of a silicone-based concrete sealer that had been specified by the architect and the owner. It was interesting that the claim that the junior college project, that the junior college was making, was the installer should have removed that silicone-based concrete sealer. But the sealer that was specified was intended to be a penetrating sealer that was supposed to do 2 things. It was supposed to be an aid in curing the concrete, and it was supposed to be a permanent moisture vapor mitigation system. Well, most adhesives don't play real nice with silicone-based coatings. They don't stick. So the college said the installer should have removed it. The installer says you guys specified it to put it there for a particular purpose. And if you believe the manufacturers, the silicone product manufacturers literature, if you believe their literature, this stuff penetrated down into the surface of the concrete by about 1/8 of an inch. How are we supposed to remove that much concrete? That's a lot of concrete to remove.
Wow.
So anyway, we went back and forth, but those are the types of arguments that you get. What we eventually discovered was a condition called alkali hydrolysis that was causing the degradation of the adhesive. Jonathan, you can forward on now to a couple of the other slides. Yeah, these are the types of bubbles and stuff that we were seeing here. You can see the bubbles in there. And then Jonathan, you can go on to the next one. So you can see right here. So this is stuff that we pulled up, right? Now, you can see that, you see this gold colored stuff that's on the back of the linoleum?
Right.
Yes.
Yeah, that's not the linoleum, that's the adhesive.
That's the adhesive, right.
When you look at the concrete, you can see that that's pretty much bare concrete. The adhesive didn't bond to the concrete at all.
Wow.
Not even close. Okay, next slide. Okay, so this is us when we were setting up doing our testing. We did the calcium chloride test. So we did 2 tests at each location, one over a prepped area. You can see that where the lighter concrete is seen. And then we also did one over a non-prepped area. And we did that just because we wanted to see if there was really going to be much of a difference. And there was only a slight difference, but it wasn't an appreciable difference. You can see in the forefront of these two, the picture on the left, you can see these little red tabs. That's where we ran 3 relative humidity tests at each location. So we did 2 RH tests, 2 calcium chloride tests, and 3 relative humidity tests. And as you can see, you see where that linoleum is pulled back. You can see most of that is gold. That's all adhesive. Okay, so the next slide is...
Quick question, Roland.
Sure.
What is the black substance on the concrete? Is that just dirt?
No.
Okay.
So go to the next photo, the next slide. Okay, so let's address that black, okay? So I asked the installer, who was my client, I said, what color was that concrete when you installed that floor? He says, it was a light gray. I says, well, now it's a dark black. It's almost a charcoal black. He says, yeah, and it smells funny too. And I says, yes, it does. Well, you see this photo here on the left, and you can see kind of right in the middle, you see what looks like a bunch of little water droplets.
Mm-hmm.
Okay, there you go. That's it right there where the pointer is. Okay, so what happened is in many of the locations, as we pulled the linoleum up, within 30 seconds after we would remove the linoleum, not in every location, but in many of the locations, these little water droplets started to form. And we were puzzled by that because when you actually touch them, it wasn't water. It was a liquid, but it wasn't water. It was kind of an oil type of base. It was some pretty interesting stuff, and the pH of that stuff was running between 11 and 12. So that's enough to burn you. So it was determined that was a highly alkali, they just termed it a highly alkali liquid that was emanating from the concrete. And we never pursued that any further. But if you see this picture on the right, and you see that that little piece of linoleum that's in the middle, that's the back of the linoleum. And if you look at that kind of brownish discoloration on the back, that is adhesive that suffered from alkali hydrolysis. Now, alkali hydrolysis will essentially deep fry an adhesive. Alkali is alkali can burn you. It can cause skin burns. It can burn just about anything if it's strong enough. And in fact, and I didn't realize it until I started doing research for this particular project a few years ago, alkali hydrolysis is also a method that funeral homes are going to do cremation of bodies now.
Wow.
Yeah, it was kind of icky actually, but alkali hydrolysis, they're starting to use that instead of the old natural gas furnaces. It's, you know, and it's actually kind of interesting, a little too morbid to go into here, but if it'll do that to a body, I'm sure it wouldn't have any problem messing around with an adhesive. You know, so we actually, my client, we ended up paying some money, not because we did anything wrong, because we didn't. And at the time when the stuff was installed, they even took surface pH measurements, and the pH measurements were within the guidelines of the manufacturer's adhesive. We ended up paying because in these large construction defects, everybody pays. The way these go is you'll eventually end up going to a settlement conference, and you'll have a number of these. And the way it works is everybody gets around the table, and it's kind of a cat and mouse thing. Everybody tries to figure out who has how much money. And eventually, after you've had a few of these settlement conferences, everybody has a good idea of what the particular carrier, the insurance carrier, is willing to pay. And the way these things are finally settled is everybody throws money into the pot, and that becomes the settlement. It makes no difference whether you did anything wrong or not. What makes a difference is, do you want this thing to be over, or do you not want it to be over? If you want it to be over, you're going to throw some money into the pot and get the hell out of the room. And that's the way these things settle as well. And then what happens then is those settlements are usually termed or deemed to be confidential. So nobody knows how much anybody, you know, threw in.
So what's the solution on this one? Let me see if I've learned anything from so far here. I guess you're tearing all that old flooring up. You're going to have to remove 1/8 of an inch of concrete and then redo it.
Yeah, except that's not what the college did. What the college did is they took the settlement money and they set some of it aside in a repair budget and just started having people come on out and repair the bubbles as the bubbles showed up.
Wow.
Which is what we had originally offered. We said, oh, we'll just come on out, sure, in perpetuity. We'll just keep coming out repairing bubbles. You call us and we'll repair it. But no, that wasn't good enough. But once the settlement was achieved, now that is what they are doing. Because let's face it, they don't want to close down their whole school, though the past year, who knows what might have happened during the past year, because it was all closed down anyway. But they don't want to close down their whole school. That all 14 floors, those were all classrooms and learning centers and everything. They can't close that all down. So essentially what they did was they took a share of the money, put it aside, and then just paid for ongoing repairs. They repaired, the bubbles, but didn't get into the systemic fix.
Cliff?
Yeah, I guess I have a question, or two questions actually. Number one, you talked about repairing the bubbles. Can you describe to the audience how that would be done?
Yeah. So in a very small bubble that's only a few inches in diameter, what they can do is they will inject a high solids adhesive right through the linoleum using a hypodermic needle.
Right.
Okay. Now, for larger bubbles, what they will do is they'll do, depending on how large, but what they'll do is they'll cut the affected area, but they'll only cut on 3 sides, so they've created a flap.
Mm.
Then they'll flap the material back. They'll scrape away all of the existing adhesive and stuff. They will try to abrade the surface of the concrete as much as possible. And if possible, they'll like to leave it open and let it breathe for a day or two. And then they'll come back, and what we ended up doing for the areas that we pulled up when we did our testing is they would put a skim coat of a cementitious material over the concrete. Then they would put new adhesive. Then they would flap the material back, but because it had bubbled, there was an excess of material. So they would have to flatten it and then retrim it to fit. And then they would go ahead and use normal procedures to seam seal those 3 edges. And that's the way. Now, in other areas that were too large to do that, they would say, okay, so let's take it from that wall to this seam. Let's pull it up. We're going to throw this stuff away. We're going to do the same prep that I just described, but now we're going to put in a new piece of linoleum. And we try not to do that because the new linoleum, even if it's the exact same color, doesn't match.
Mm.
And so, you know, but those are typically the 3 different ways that we would approach the repairs at this project.
What if they were to have removed the linoleum, could they have put carpet down, or you don't think that would have worked?
What kind of carpet? They could have put
Squares, like squares.
Yeah, they could have put carpet tiles down, but that becomes a maintenance nightmare. As much as I actually do like carpet tiles, you know, they are hard to maintain, and I can hear my phone's lighting up now from carpet manufacturers going, "What the hell are you? Are you nuts?" But you know, carpet is carpet, and you know, it doesn't clean up as easily as, say, a hard surface resilient floor like what we had here. But yes, they could have put a carpet down.
Okay.
Interesting. Hey, Cliff, anything else?
Oh, good. Thanks, Joe.
All right, let's get moving here. We've got to get to halftime first. We want to thank our sponsors. When we come back, we're going back with Roland Vierra and Bob Blochinger, and we're talking flooring-related issues. Our marquee sponsor, Instascope. More jobs done faster with the future of IAQ assessment technology. Unlimited samples, instant results, and cloud-based data at instascope.co. Our association sponsors are AIHA, Healthy Workplaces, A Healthier World at AIHA.org. ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science at acgih.org. The Cleaning Industry Research Institute, see more deeply through science and research at CIRIScience.org. The Indoor Air Quality Association, promoting the exchange of indoor environmental quality information through education and research at IAQA.org. The Restoration Industry Association, the granddaddy of the restoration industry, network with leaders at restorationindustry.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry at IICRC.org. And Healthy Buildings America 2021 in Honolulu, Hawaii, November 9 through 11 at hb2021-america.org. IAQ Radio industry sponsors are AEML Laboratories, free shipping, great pricing, same-day results with no rush fee at aemlinc.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us at particlesplus.com. Gray Wolf Sensing Solutions, Over 20 years manufacturing accurate, reliable IAQ instrumentation for portable, short-term, and continuous monitoring at graywolfsensing.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations at tsi.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers at healthyindoors.com. All right, we're back for the second half of our interview. Let's go right to the next case study with Bob Blochinger. John? Here we go. Okay, Bob, we're looking at hotel casino moisture testing. All right, this ought to be interesting.
Yes, this is the Hard Rock Cafe Guitar Hotel in Hollywood, Florida. It's about 30 stories tall. It's the actual form of a guitar. Very interesting project. And what you see in this slide is one of the 1869 tests I did. My job was to test the theater. I do not know how many thousands of seats it had in it, but it had many different floor coverings known to man, such as LVT, VCT, sheet goods, and carpet tile and carpet glue down, depending on what location within the building. I did approximately 60 tests on this project. And this is a resulting test of 34 grams of moisture collected in that little disc. And I had different readings in different locations depending on where I was. The HVAC system was a combination of permanent and temporary depending on what part of the building I was in. Next slide. That's just one of my guys grinding the concrete according to the guidelines.
Okay.
But this is a pH test, and you can see the pH is elevated, which has a issue with adhesives because on other jobs, I had to do some research on the adhesive pH acceptability, and most of the adhesives today cannot go more than 10 in pH. Here's just another calcium chloride test in a room. I think this was going to be an IT room because I see plywood on the walls. I'm just showing these photographs were for the client to show my mythology and that I was following the rules.
Bob, what was the original complaint here?
Oh, there was no complaint. This was prior to installation, I was asked to test the concrete for acceptability of a adhesive applied floor covering, such as resilient carpet, whatever.
So that's great. They were actually being proactive in this case.
Yeah, absolutely proactive. That's just another photograph of a test. And the next photograph, I believe, is the conditions to which we were working. You can see it's an open ceiling. You got the guy at the end on the lift, on the scaffold. And again, all trades known to man were involved in this project as I was trying to do my work. That was my crew. They were doing the 2170. And again, these photographs were for my client. You can see that's number 19. Drilling down, the slabs were of different thicknesses. So I went the 2.5 inches down, went through the process. At that time, it was the 24-hour test protocol. 24.
So it had to acclimate for 24 hours,
yes.
your probes. Okay.
Yes, there is the guitar. The building in front of it is the one I was working in.
Next, John.
There you can see there was basically no HVAC system operational with 82% humidity, 81 degrees. Basically, the inside conditions were just a few points lower than the outside conditions. And you can see the grains per pound is 130, which is it's more than 100.
And your dew point's pretty high up there too, huh?
Yep.
Next one, John.
This is in a different location for a different reading, so you can see it's a little higher here.
Okay. Next.
Another pH test, and it's running 11, 12, however you want to look at it. This particular method of doing pH reading, the old strip paper, I find to be a judgment call, and I'm using the digital meter, which is a little bit more accurate, but most of the concrete I test in this area, there's nothing below 10. Here's a bond breaker. This is a sweeping compound that's got some oils in it, and it's used, of course, to clean the concrete. So later down the road, this was an evidence photograph for the flooring installer to let him know that some areas will have sweeping compound residue within the concrete surface, which is a bond breaker.
Wait, can you explain a little bit more what a bond breaker is for me, Bob?
Okay, a bond breaker within our industry is any material that will break the bond between the floor covering and the substrate it's applied to. In this case, the sweeping compound has some oils in it. It leaves an oily residue. And in the case where water and oil don't mix, we have a water-based adhesive that will not attach to the substrate because it's full of oil residue. Other bond breakers could be, again, high alkalinity, high moisture content, but typically it's a bond breaker is a oil-based material that's still in the substrate.
Next, John.
That was part of the theater. Again, this is representative of this area I was working in for the client. And these are actually seating areas, the different rows. And I was testing them as well because they were getting an LVT product.
So that last one, let's talk a little bit about that one before we move on to the next one. How common is it for you to get this type of job? I mean, is it common enough that are people actually bringing in third parties to, make sure that everything's prepared properly?
It's becoming more common because of all the lawsuits that we're having in Florida. I just got a phone call from another flooring contractor who asked me to quote for him testing protocol prior to installation. Some of them are putting a figure, a number to the bid packet, and it's becoming more prevalent because it's in the architectural instructions, in the architect's plans, to use a third-party tester. Also, on the can of glue, on the carpet wrapping, on the LVT box, it's in there to do testing according to the ASTM 710 using 1869 and 2170, or maybe perhaps another method, but using a meter like a Tramex concrete encounter is a preliminary indicator that if, as far as I'm concerned, when I get over 3, I start talking about doing the testing, the other testing protocol. But it's becoming more and more common because of the extensive failures that are here in our climate.
And what was your report after doing that particular inspection? It looked like they had elevated relative humidity. How do you handle that?
Okay, I did note that everything that we had about a 40% elevated. And at that point in my commentary, which I include in all my reports for moisture testing, the substrate needs to be prepared by some grinding in certain areas because of the sweeping compound, the paint overspray, the drywall mud and whatnot. And after that, a moisture barrier, perhaps a single coat or a 2 coat with a roll-on liquid should be used, and a high quality adhesive that has elevated moisture qualities to it.
And that's because this is all open to the elements and you're not going to be able to control.
No, it's not open to the elements. It happened to be not under complete HVAC when I was there, but it's an enclosed theater. I'm going to say it's probably 7,000 seats in there. So it's
Mhm.
quite large. And in order to not have us come back and do any repairs and such, I call it an insurance policy to put down a sealer and do the floor prep correctly. And it was done that way.
Okay, let's go to the next one. John, we'll go over to next, Roland's next case study. All right, so we've got a retail showroom project. We've got some LVT plank. Roland?
Yeah, so this was actually similar to one of the projects that Bob had talked about earlier. We ended up having adhesive seepage between the plank joints, and we found excessive slab moisture. The slab was moisture tested prior to the floor being installed. And not only was it tested, but the testing indicated that there were adverse or excessive moisture conditions that exceeded what the adhesive and the flooring manufacturer required. However, the owner and the GC decided, yeah, the slab was more than 20 years old, and it could have been maybe a testing error, and we never had problems before, and blah, 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 blah. So they decided to disregard the testing results and to just go ahead and proceed with the installation. And I suspect, ultimately, that the issue was the concrete was wet at the time of installation. And what that means is the adhesive never fully cured. And because it never fully cured, it was able to, I'm going to say re-emulsify, but it never really solidified to re-emulsify. It was always on the damp side. And with the moisture that was emanating from the concrete, I think it just kept that adhesive in a semi-solid state. And as more moisture and the effects of alkalinity, increased over the length of time in service, the adhesive just fully gave up the ghost. It just broke on down. Jonathan, if we can see some photos, I don't remember which photos yeah, there we go.
There we go.
There we go. So I think that picture on the left is pretty self-explanatory. When you walk on this stuff, that's what happens. And then you can see on the picture on the right, all of those smudges. Yeah, that's adhesive that is oozing through the joints. Now, this is an LVT floor or LVP, and so it's got a lot of joint area. And because it's got so much joint area, it's got lots of places for that excessive volume of now emulsified adhesive to escape. And every time, it acts just kind of like a bellows. Every time you step on it, okay, you're forcing, if there's an excess amount of material underneath it, you are forcing that material that's underneath the finished floor to ooze up. And if it has a pathway, which would be at a joint, okay, it'll ooze right through the joints.
Go to the next one, John.
Okay, so this is just, more of the same. And you can see it all on both of those pictures. And this is pretty annoying for a retail showroom. They're trying to show themselves off as being, fairly clean and fairly decent and fairly stylish, and but their floors are a mess. An absolute mess.
They're selling flooring?
No, they're not selling. No, not these people. They're not selling flooring. But their concern was we ain't going to be selling much of anything if our retail showroom looks like this.
I got you. Let's go to the next one, John. All right, so here's what
these
you're
were
looking at.
after we pulled up some sections and I took a look with my trusty rusty Tramex. These were some of the readings that I was getting. If you look at that picture on the left, we've got 97% RH. And the picture on the right, 96% RH. Now, the manufacturer of the flooring in this particular thing actually had a specification that said they're good up to 85%. And as you can see, we've exceeded the 85% mandate by quite a bit.
Roland, just to clarify for our audience, when you're measuring the relative humidity and temperature, what's the location of your meter? Right at the floor?
Yeah, right at the floor.
Okay.
So now this test is part of what's called the in situ relative humidity test, ASTM 2170. And what we do is we drill a hole into the concrete, the body of the concrete. And the hole goes to a depth of 40% of the concrete thickness. And then after we drill the hole, we clean it, vacuum it, brush it, and we put a plastic sleeve in and we cap the sleeve. And then the sleeve sits for a minimum of 24 hours. And then I will come back after a minimum of 24 hours and I'll put a temperature and RH sensing probe. Okay, I'll open the hole, drop the probe in, and recap the hole. And I like to let those sensors sit for about an hour and a half or 2 hours, but I don't like to let them sit more than 6 hours because the actual sensing element that is made by a different company, not the company that makes the probe, but if you read the actual sensor data sheets itself, it said if you leave them too long in in an adverse condition, which would be a condition where there's, say, a lot of moisture, a lot of RH, even high alkalinity, they'll be subject to a condition called creep, where after a certain number of hours, the sensor essentially gets overloaded. And so you might be reading 80% after, say, 2 hours, okay? But after 2 days, you might be up to 94%. Well, the RH in the hole hasn't changed. What has happened is the sensor is becoming overloaded because it's a condition that's over a long period of time. It's an adverse condition for the sensing element itself. And so the sensing element just keeps increasing its reading, and that's called creep. So because of that, the sweet spot for me is usually right around 2 hours. Tramex, who I use exclusively, Tramex recommends not exceeding 6 hours in terms of the probes being left in the hole. So like I say, 2 hours, and that'll do it.
I think it's a good tip for our audience. All right, let's see what we can. Oh, this is a little different project. So we're going to run, just first of all, I want to let listeners know we had announced in advance we're going to go an hour and a half today so we can get all these case studies in. And we're going to go ahead and jump straight to your next one, Roland. But before we do, what was the outcome on the last one?
The last one was they pulled all of the material. They retested the floor again. I shouldn't say they, I should say I retested the floor. I once again came up with extraordinarily high numbers, and they decided to go ahead and put down a two-part epoxy sealant system and then reinstalled the floor. And that's been a couple of years. I've never heard nothing from them since, so I'm assuming it's working.
What are your thoughts on why it's so high?
Yeah, this is another important tip. Okay, so this was a conversion from warehouse space. The slab was 20 years old, but most people need to understand that warehouse spaces typically don't have a vapor barrier beneath the slab. You know, wherever anyone can save money, they do that, and they figure, it's just a warehouse, who the hell cares? So they will not put a vapor barrier. In fact, I've got some pictures somewhere. I was trying to find them and I couldn't, where I've got a new warehouse facility going up not more than 50 miles away from here. And every time I pass it, I take a look and I take some pictures. And you can see they had the layout, they had all the forming and everything like that. And you can see they've got a vapor barrier where the offices are going to go. But then they've got like 50 or 60,000 square feet, which is intended to be warehouse space that has no vapor barrier at all. Yeah. So you need to be extremely cautious when you're working on these repurposed buildings. This was originally a warehouse space, and now you're going to convert it to a usable indoor space, whether it be condos or whether it be, you know, retail or offices or anything like that. You've got to be really cautious, because if you're repurposing old warehouse space, you're likely to have a moisture problem.
Yeah, they're also oftentimes not conditioned. Does that also affect the potential for moisture?
Well, that can, but what they've done in this particular project was, because they had converted all the warehouse space to usable retail and office space, they all had HVAC installed. So now it's definitely all, you know, all conditioned. But what we don't know is, you take a concrete slab that's been living in an unconditioned area for 20 something years. Now all of a sudden it's conditioned. You don't know what effect that's going to have, you know, on that slab vis-a-vis moisture. So
would you recommend that building owners who are going to do this, once they get it, you know, covered in and conditioned, that maybe they add a little dehumidification to help bring that slab back to a drier condition?
No, I think not necessarily that. And I'll tell you, out here in California, we don't rely on dehumidification very much. Mm-hmm. But I'll tell you what a recommendation I would make, and I have made, and I do make, is I think that they should do a couple cores through that slab. I think they should have the slab analyzed through petrographic analysis. And I think that they should take a look at the base that's underneath the slab. Is there a vapor retarder there? Is there sand? Is the sand wet? Is there a capillary break? What's the condition? What type of media was used in that capillary break? I think those are all things that need to be answered, but is seldom ever done. And that alone, the knowledge that can be gained from that alone would go way far in avoiding a lot of these problems. Typically, if a project even is more than 5 years old, nobody can find any of the original documents. You can't find any of the specs. You can't find the blueprints. You can't find anything. So can you imagine going into a situation like this blind? You just have no information.
Right.
And you decide to spend $500,000 anyway. It's silly.
Yes. All right, let's go to your last one here. I believe this is your last one, and let's try and get through this one real quick, and then we'll go through Bob's final two.
Okay, all right.
There we go. Right. So we got a hospital project. So what do we got here, Roland?
Okay, so we had LVT that was glued to an above-grade concrete slab. And this was an interesting thing, because all of the LVT was releasing from the floor. And this was a huge hospital, and they couldn't figure out, and it was happening all over the hospital, but it wasn't necessarily consistent. It wasn't 100% of the floor, but it was 60, 70, 80% of the floor. So it was a lot of it. And what they ended up having is it was releasing from the floor, and it was developing what's called a negative curl. For you hardwood people, that would be the same as crowning, where the center of the individual plank is raised up against the above the outer edges of the floor. Jonathan, if we can go on and take a look at a picture or two.
There
Okay,
we go.
so this is exactly what we were seeing out there, and I think both of these pictures really demonstrate this really well. So we can see the negative curl, which is the outer edges of each plank. Actually, what's going on is the outer edges are actually curling down, and because there was no restraint from the adhesive, okay, it was forcing the center of each of the individual planks to raise up. And this was happening all over the hospital. And for
Huge
some
issue.
reason, they didn't like it.
Mhm.
So,
that's a bit of an
I don't
issue
know how
there.
many more pictures I have, Jonathan, but if there's
Go ahead,
any more,
John.
we can take a look. Yeah, there we go. Okay. So through our evaluation, we pulled a number of planks, and I'll tell you, it was very easy. All you had to do is the little pocket knife just started a corner, and once you got one corner released so you could grip it with your fingers, the plank pulled right up. It was, it was not that difficult of a situation. And what we found was the adhesive was really well bonded to the concrete. Unfortunately, the adhesive didn't bond at all with the planks in these areas that had failed.
Interesting.
So we had some evaluations done on the planks themselves,
Let's go to the next one, John.
because what we thought was, that's okay, go back. What we thought was, we thought that maybe the planks were experiencing a negative curl immediately after being placed into the adhesive bed, and because of that, they never married with the adhesive, and that was why. Well, that was wrong. What actually happened was there was a contaminant on the planks. It was a form parting agent that the manufacturer had used as the floor was being manufactured, and they didn't remove it. And so this was preventing the planks from properly setting into the adhesive. And so what we ended up doing was, first of all, they sent a whole bunch of new flooring. They eventually replaced all the floor in the hospital, and it was a tedious job because they didn't close the hospital, but we could only do about 500 feet in an evening. It was all night work. You could only do about 500 square feet in a night. And so, but that's eventually what they started doing, and they started at the top and they worked their way down. We did a number of bond studies up on the 7th floor of this hospital. The 7th floor was completely unoccupied and not built out yet. And we did some bond testing. We installed some new adhesive, let it set for a couple weeks, and then tried to remove the tile and had good results. The manufacturer had suggested that maybe you could pull the affected tiles and just sand the back and then reinstall the back, or reinstall the tile, and the hospital said, no, I don't think so.
That doesn't sound acceptable. Wow. All right. Well, thank you, Roland. Let's go to Bob. I don't know if we have one or two left for Bob. John? There we go. All right. So this is case study 5. So we do have 2 to go here. Restaurant moisture testing, Bob. What do we got? Let's go to the next one. There we go.
Here's another calcium chloride test with an elevated result. It's 29.1 grams, and typically these vapor vision kits run. I'm sorry, this is the beginning. Yeah, they always run about 29.1, 29.0 grams in there, and so that's the beginning of the test.
Okay. Next.
There you see the concrete's at 4.8%. Unfortunately, my finger's over the relative humidity, but to me, that was an elevated response. So therefore, I I probably wrote in my comment section that some sort of moisture remediation needs to be performed.
Next.
All right.
What do we have here?
We have either was a very cold day in Florida or the AC is working very well.
Wow.
But there's in the whole temperature. This was, now I remember, this was in a kitchen in a restaurant that's being built, brand new restaurant in a hotel. So this was the kitchen, and therefore everything was operating very cold. So because we got now this is in the hole, we have 68, 67 degrees with a 93% humidity. So failed. Everything was elevated.
Interesting. Next.
That's a floor plan, which I typically use to scope out where I'm putting the tests. The tests are not notated on here, but I always get a set of plans to work with it. This way, for future reference, they know where the hot spots may be.
I'm glad you threw that one in there. Go ahead. Next. Always good to see.
This is a result of the test that you saw earlier. We have a 34.5, which you can't really tell how many pounds per square foot this equates to until you do the magic secret formula. But in the end, it's high.
In the end, it was what? I'm sorry.
High.
High. Okay. Next.
That's the restaurant condition under which I was doing the testing. And now that I remember where it was a cold day in South Florida.
Gotcha. Next one.
Like below 70, we had to wear long pants. And that's another photograph of the restaurant. I always take a picture of the site so that people understand the conditions I was working in.
Good. Good tip. All right. What do we have here?
Well, another hole in that restaurant with a 94% humidity and a 71 degrees in the hole. Typically, the slab temperature at the surface runs between 69 and 73 degrees Fahrenheit on almost any slab here in South Florida. That is under HVAC operation. If it does not have HVAC, it's going to run into the high 70s and low 80s, which is not good for resilient flooring that's going in with adhesive.
Next. Oh, so what was the solution on that one, Bob?
They put down a moisture barrier for insurance against future damages. On that restaurant, I was sent to test the kitchen slab, not the dining room slab. This is just a kitchen because it was getting one of those epoxy seamless flooring products that they get applied. And they want to be sure that, the moisture is under control. So there was a barrier put down and then the colored topping on the surface.
Were you working for the building owner or the flooring contractor?
Most of my work is now for the flooring contractor. I have a few commercial guys that use me on everything they do. And from time to time, I get called in by a general contractor.
Interesting. I'm curious, Bob, you go out and do a pre-job kind of inspection. I mean, what's that going to cost a flooring contractor ballpark just to get you to go out there for, a day or two and evaluate the flooring conditions?
Well, first of all, I wouldn't go out for a day or two. I'd go out for a couple hours. Because, and I try to go in the morning when all the activities going on. So I see the conditions as far as the labor management and that sort of thing. And who's working there, because I'm usually sent out on that type of inspection, maybe within 4 weeks of me actually doing the testing. And I use my impedance meter at that point as well. So as far as cost-wise, $300 to $600, depending on the size of the job and how long it takes and how many people I have to question and how much time I need to research what has been done to date. And of course, I need to know the flooring products going in.
So it's not a huge expense for the flooring contractor to get you out and to be on the safe side before doing this kind of work. That was the point I was trying to get to. I appreciate that.
It's quite frankly a cheap insurance that it has been documented by a third party. These are the conditions we have to work under because, quite frankly, disclaimers by a flooring contractor don't work. They don't hold water. And this way it opens the door for future research and testing on a slab.
Interesting point. Very good. All right, let's go to the last one here, John. We can flip through this one, then we'll go to the roundup. I want to warn Pete and Cliff, we're running a little behind, but let's go ahead and do this. Industrial warehouse, ASTM moisture testing. Next. All right, what do we have here, Bob?
That's interesting. That is a electric power plant that's going in South Florida. I'm actually going back Monday to do a retest because when I went for testing, it's to the building to the left by the red crane. The HVAC system was not operational. The huge garage bay doors were still not installed, but they wanted me to go out and do testing. So of course, I used, 13 test sites, all 2170, and each one was highly elevated.
Next.
There's the building with the door open.
Next.
There's the conditions we worked under.
Interesting. Next.
Again, the conditions.
One more, John.
These are all for the flooring contractor as proof of what he has to, I'm going to say, discuss with the GC that, hey, we can't put flooring down and look at all the stuff you got laying around.
Great point. Okay, good picture too. Next.
Again, more of the same.
Same. Next. All right, here we go.
There's a hole. At times it's very difficult to measure the thickness of the slab. Nobody knows how thick it is when you ask them, and there is a way of doing it by drilling an 1/8 of an inch wide hole until you hit dirt. But some of these slabs could be 12 inches thick because of the rolling traffic and the usage as a warehouse. So I typically go down 2.5 inches at the most, because that's where the moisture accumulates through the upward push. Actually, it sits at the first 3/4 inch of a slab. The little white dot to the left, I drill the skin off, and that's where I do my pH test.
Okay. Next.
There we're doing the results of a pH, of a Tramex evaluation for moisture.
Next. Okay.
That same hole, look, you can see we got 97%, 75 degrees Fahrenheit, which tells me that we do not have HVAC operations going on.
Interesting. Next.
There is a further inside, in I think it's in their computer room, which had temporary HVAC system going.
Okay. Next.
There's another hole with high results as well.
Next. Okay, so what's the outcome on that one, Bob?
I'm going back this coming Monday to do a retest of all 13 holes because the HVAC is now operational for 3 days, which is a guideline on the ASTM.
Oh, okay. So once it's operating, do you expect it will get much better?
Yeah, it's going to get better, but this is all about cost saving for, if you have, let's see, 13 tests, that's probably 13,000 square feet or 15,000 feet I'm going after. And if they have to do a remediation, you're looking at $1 to $3 a square foot. It gets pricey. And to get a change order that has not already been preloaded for moisture remediation is going to be a very difficult fight to get the wallet open.
Interesting. All right, gentlemen, we appreciate this very much. Let's go to the roundup. All right, let's start with Cliff. Cliff, any final thoughts or questions for our?
Yeah, I did. Bob, the last thing that you mentioned was he talked about this high cost in the event of moisture remediation. Can you just give some tips as to how moisture remediation would be done? What are some of the methods or what's included?
The first point or the first act is to take the skin off the concrete, perhaps a 1/16 of an inch, perhaps a little less than that, where the skin is the surface that the steel trowel whirly-birds actually create, where the cream of the concrete is risen to the top and is very smooth and slick. Smooth and slick is not an acceptable surface for any adhesive, so it's got to be open. At the same time, it will not accept any moisture remediation products such as epoxy, whatever. So you have to remove the skin and open up the concrete so it's porous. Grinding will do that, and bead blasting is the end all to do that. So the difference cost of grinding to bead blasting, again, it goes on the square footage amount. Could be $1 to $3 a square foot for that action. Then you got the cost of, are you going to use a epoxy-based 1-part, 2-part liquid sealer that you can apply with a paint roller and put on 2 coats? Or are you going to use a real heavy-duty one that gets poured on? It all depends on, number one, the moisture content, the flooring covering that's going in, and the building usage. For instance, I had an airplane hangar down in the Keys with high elevated moisture in it, and the epoxy it already had an epoxy coating put on it, and the epoxy was bubbling and cracking and flaking. Well, they reversed. They did not do correct bead blasting. They did not do moisture testing, and then they reversed the mill thickness of the 2 coats of product. The clear coat was thicker than the top coat, which was the color coat. Should have been reversed, because when they dropped the nut, it was a helicopter repair hangar. When they dropped the wrench or a nut, it would crack and flake the surface. And then when I brought out my 6-foot chain that I polish every week, so it looks nice and clean, I used that for delamination testing. And at that point, that's when the GC walked out, because I knew I had him. He knew I had him.
While we're on this, one follow-up from a listener, which I think is important. Do you do any precautions for silica exposure during this testing or remediation?
Yes, we use HEPA vacuums, for one thing. And on the one photograph you saw, I had I have a vacuum that is used to suck up the remnants of a furnace, the ash. So I bought that one because, well, first of all, stainless steel, so it looks good, and it's not a Home Depot, one of those plastic vacuums that really everyone has. And then there's a attachment from Hilti, a drill. The drill is maybe 12 to 18 inches in length, and it's hollow. It has 2 holes in the bottom. It has a rubber coupling to it that is attached to the vacuum hose. And as you drill the hole, the dust is sucked in through the circulating of the vacuum suction, is sucked into those 2 little holes and brought up through the center of the drill and into the vacuum. And it's basically 90% dustless.
Excellent. Cool. I see Roland also replied through the text, so that's a great tip for me and Roland are having fun on a private chat here on this silica deal, and Cliff is smiling too, because he kind of remembers the whole silica discussion in Dublin, if you recall. Oh, yeah. So all right. Well, Pete, you know what, before we let Pete wrap things up, I got a quick meter question for both of you. I get the impression from being a part of all these Moisture Mob presentations that you guys feel that moisture meters maybe don't, and I want to say the current the current moisture meters out there could do a lot of this work, and that maybe we don't have to do all the, the dome testing and the calcium chloride and all the drilling of the holes and all of that. And I understand that, you have to follow certain standards and guidelines, but I just wonder if you could comment on the latest generation of moisture meters and whether they may eventually kind of replace some of these older tests. Let's start with you, Bob.
Nothing will replace the ASTM testing that we have available. The reason I say that, for legal reasons, I use 3 manufacturers. My primary is Tramex, but I also use the other one and the other one. And because the last time I got in trouble from our watchdog friend for saying the D word.
You can say whatever you want, buddy.
Damn it.
Yeah, damn it. So anyway, the impedance meters that we're discussing are an indicator of a problem or an indicator of no problem. And depending on where in the world you are, if you, let's say a 2.5% reading here in South Florida, well, it's borderline, what do I do now? Basically, it opens discussion on what we want to do next. If you have it in the Midwest or in a dry climate, well, it's okay to go. So it depends on your local, but these meters are designed as an indicator of what's going on. And that's why if you have, let's say, 1,000 square foot job site, you may do 20, 25 locations within that 1,000 square feet to see what the readings are.
Roland, what are your thoughts?
Yeah, I think first of all, I've used a few different meters in my time. I pretty much have settled on my favorites, and for concrete work, Tramex is my favorite. What I like about them is they're extremely repeatable. That to me is a big thing. I can take a moisture reading today, and I can come back to that same generalized location tomorrow and get almost the same reading. Not all meters are that fine-tuned. I think that when a manufacturer or an architect or an owner or anybody else specifically mandates a particular test, then that is the test that needs to be done, no matter what you might know, and you might know better. But when they say you've got to do ASTM 1869 or ASTM 2170 or 2659 or whatever, that's the test that you have to do. Because of that, I think that probably, at least for the next 15 years or so, we are going to always be doing probably the relative humidity test, definitely. The moisture vapor emission 1869 is kind of fading from view. I will use the 1869 moisture vapor emissions every time when I'm doing forensic work. But when I'm out doing a pre-project moisture testing for a contractor or an owner or something, if it's not specifically called for, I won't use the 1869 because it's too easy to fake. But overall, I love impedance meters.
Okay. Well, thank you, gentlemen. Let's turn it over to the global watchdog for final thoughts.
Okay, thanks, guys. First of all, Roland and Bob, I really appreciate all the hard work on this. Really, all the Moisture Mob guys, you guys did fabulous. I think that when Bob started with his case studies on the standalone thing that he did before, we moved to this model, it really opened up, I think, a whole new style, really, for the IAQ radio, and a lot of the feedback that we got from the audience. And so we're really planning on a lot of future shows to do some PowerPoints and some slides as part of the show over and above the interview questions. I think the audience likes that. It creates kind of an interactive approach and really can really dig deep, from a technical aspect, which is the heart of most of our shows. We have business stuff, but a lot of them are really technical stuff that the audience likes. So every once in a while, doing these hour-and-a-half shows are really required to really do justice to them. You don't get into two-part shows, but sometimes that's just what the topic is. The Now, the one thing I want to do, that's an old Mikey, the Mikey Jersey boy. You know, he doesn't call in very often, old McGinnis boy. So I'm not so happy that he was on there. And, you know, for those of you that don't know in the audience, Mike, early in his career, was an enforcement officer for OSHA. So he really digs in big on these issues. And when in that little a message, he says it's more to it than that. I privately told him I'm going to dress it in my clothes. And this is what I want to say about this. It was just briefly covered in what Roland wrote and others. These guys, there is more to it than confining the silica dust. And I think there is an OSHA standard or something on it, or there are guidelines that really should be followed for health and safety issues. I will tell you this, and I think Cliff was aware of this. One of our certified restorer candidates, who is a certified restorer now, long-term industry guy. He's actually in South Florida, Bob. And besides being a restoration guy, he's also a public adjuster. And he actually did his formal thesis and research paper on a silica project that was very impressive. Now, I don't know. I can't really recall, to be quite honest with you, whether that project was confidential and could be shared or not. You know, they have a research paper requirement, which oftentimes we're able to publish those in the CNR magazine, but the formal reports are usually have confidential customer information when they're redacted. So I guess what I really want to say is that the industry and the professional restoration guys are aware of this, as are certainly the third-party guys who are, you know, much more highly technical, competent in that area. And I do think this is something that people do overlook, and they're not on top of it as much as they should be. And I think that was Mike's concern. And Mike, I just want to let you know, trust me, Roland's particular, I know firsthand, he could give a seminar on that. And anyway, in Dublin one night, we got into a little heated debate on that, and it was actually pretty entertaining now that we reflect back on it. So I did want to comment on that. The other thing I guess I want to say about this show, and I think we covered it, there were three main areas that I thought were very important for this show. The first thing was to really just talk about the importance and the independence of doing the third-party inspections and the role that they can play. Even though these guys are kind of flooring guys, you know, they're much more beyond that, because, you know, water and through gravity goes down, and floors are affected on every water loss, and it's always moisture involved, which transcends over into indoor air quality issues, restoration issues, etc. And I think they've done a really fine job in that. They have to train and educate themselves really on all the moisture and the instrumentation. And one of the points that I made in the narrative for the part 2 show is I think the industry misses the point in how important training of instrumentation is, and that people know what they're doing with those things, because guys out there with those instruments can be dangerous if they don't know what they're doing. The information that they give to the homeowners, the property owners, and even more so, the insurance companies and the managers and the people that pay for these jobs, they give them the wrong information. That's a black mark in the industry that people want to paint us with a broad brush. It's terrible. And understanding your tools is critical. And I think these guys drove that point home. You know, we could do more in that another time. But I think that's something that's missed. And I could just tell you, as a trainer and a guy in the industry for years, I've seen this firsthand. And I'll just put that out there. The other thing was the importance of floor prep. I think floor prep is missed and is very problematic in a lot of jobs. And that was involved in some of the case studies, and particularly some of the ones that Bob did, I think, on the part 1 show, and maybe Roland too. And I think you guys drove that point home. You talked about the use of the word forensic. This word is thrown around a lot in the industry, particularly in some of the, these hazardous type of cleanups and in the pandemic era. And, you know, when people hear the word forensic, you know, for the those of you old enough to remember, you think of Quincy and the pathology, you know, in that context. So I think it was important that the word forensic was defined in the application. And Roland, you did a good job of that, and Bob too. And I think I appreciate that, because these words get thrown around sometime and nobody knows what they mean, and there's too much of an overlap. So I think we did accomplish all of those things. And I thank you. I thank you all for that. And I just appreciate these Moisture Mob shows and the commitment that you guys have to them to really get good information out there. to the listeners. And then Cliff's blogs are just unbelievable. Cliff, I mean, I got to tell you, I keep saying this all the time, but the time and energy he puts in those blogs, and when they go out, they really, I think, are extremely valuable to the industry. And really, there's a library on the IQA radio site of these shows and this stuff. It's over the top. Cliff, it's a yeoman's job. And I'm not telling you that because you're my friend and my buddy.
No, you've done it. You know what's involved.
I know what's involved, and I know how serious you take it. And it's really important. And anyway, I appreciate that. And with that being said, thank you, guys. And Radio Joe, I will yield the floor back to you to do the official close of part 2 of the Moisture Mob and Forces with the East Coast, West Coast perspective. Terrific job, boys.
It's an hour and a half show that went an hour and 40 minutes.
I know. This is what happened. He gave me 1 minute to do the roundup. I mean, what can I tell you? This is what happened.
You had to get those guests' final thoughts. All right. Well, this is Radio Joe Hughes saying thanks to this week's guests, Roland Vierra and Bob Blochinger. We had a great discussion on moisture-related issues affecting wood and concrete, substrates, and flooring. Thanks, guys. I know you put a lot of time into it. We really appreciate it. And obviously, our listeners have also been very receptive to the conversation. I also want to thank the Z-Man, my co-host, of course, the Restoration Industry Global Watchdog, Pete Consigli. John, you got to have faith at the controls. We'll be back next Friday at noon with the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.